Okay, welcome to the continuation of the previous video, that is square wave generator. Now let us try to find the expression for T on and T off and try to match it with the values that what we are getting in the practical circuit. So this is a circuit what we have, and we have connected this as 1.5 kilo ohm. This is also 1.5 kilo ohm. We have connected this as 10 kilo ohm using DRB. So this is a fixed capacitor of 0.1 microfarad. And we found that we are actually getting this type of waveform. So that's what I'm showing here. You can see this is the waveform I'm getting. So this is plus Vsat, minus Vsat. This is your VTL. This is VTH. All those stuff. VTH matlab the higher capacitor voltage, and VTL is the lowest capacitor voltage. So we are calling it as VTH because there the output triggers switches from plus Vsat to minus Vsat, and VTL is where it switches from minus Vsat to plus Vsat. The voltages I have written here, I'm just showing it there. So this voltage plus Vsat 4.1, minus Vsat is minus 2.74, VTH is 1.81 volt. This is VTL, which is minus 1.5. Actually this VTH and VTL are related to this Vsat as R2 by R1 plus R2, and similarly VTL is nothing but minus Vsat into R2 by R1 plus R2, R1 plus R2. So typically this should be exactly half of 4.1, and this should be exactly half of minus 2.74. Because this is, since we are using the values, so these are my practical values. Now this is the voltage across the capacitor expression, which is nothing but V final minus V final minus V initial e power minus T by RC. So what is this VC of T? Because this is the voltage across the capacitor, which I can call it as VC of T. So this is how your capacitor voltages keep on charging and discharging with respect to time. At any given time T1, suppose if I substitute this as T1, I should be in a position to find out what is this capacitor voltage at any point of time. So now since we want to find what is T on and T off, so let us try to find out what is T is equal to T on. For T is equal to T on, so this is my initial value, this is my voltage at T is equal to T on. So I will replace this T by T on, and this VC at T is equal to T on is actually VTH. So now what is VC? VC of T at T is equal to T on, it's actually VTH. So it will reach VTH at whenever your time goes to T on. So what is the initial voltage? Initial voltage is this. So let me say initial voltage is nothing but VTL. And what is this V final? V final is nothing but the capacitor voltage as T tends to infinity. If your capacitor is allowed to charge infinitely, this will go up to plus Vsat. This will go up to plus Vsat. So I will say Vf is nothing but plus Vsat. Plus Vsat. So now I can rewrite this expression for T is equal to T on as it is now VTH is equal to Vf is Vsat, that is plus Vsat, minus of this is V final is plus Vsat, and minus of V initial is VTL and e power minus T on by RC, T on by RTCT. Similarly, for T is equal to T off, so what does this equation will go? Vc of T at T is equal to T off. At T is equal to T off, you can see at T is equal to T off, what is the voltage? The voltage is VTL. This is VTL. What is V final voltage for this during this time? So if it is allowed to go up to infinitely discharge, it will go up to minus Vsat. So V final here is minus Vsat. This is minus Vsat. So what is the V initial? V initial for this off time is VTH. So V initial, because this is the starting point of your off time. So initially this will be having VTH. So this is VTH. So if I rewrite this, this is now VTL is equal to minus Vsat minus of minus Vsat, because that's what is my final voltage, minus of what is your V initial. V initial is nothing but VTH into e power minus T off by RTCT. So I have this as one expression for finding T off, and this is the other expression for finding T off, sorry, T on. So now I know what is VTH. So VTH is 1.81. So it is 1.81 alpha equals, so what is Vsat? It is 4.1 minus 4.1 minus of what is VTL. So VTL is actually minus 1.5. It is now minus of minus 1.5 e power minus alpha A divided by 10k and zero point 0.1 microfarad. If I do all those things, I will get what is T on. So it is now 1.81, sorry, 1.81 alpha equals 4.1 minus, it is 4.1 plus 1.5 close, of course minus of minus will become plus, into exponential to the, okay, it is now minus of alpha A divided by, sorry, divided by, open the parenthesis, 10 exponential 3 into 0.1 exponential minus 6, close, shift calculate. So now I'm getting the on time as, so on time is now, the on is 894 microsecond. So this is my on time as per this expression. Let us verify from the ADK value. Let us also find what is T off. So for finding T off, what is VTL? It is minus 1.5 is equal to, okay, minus of Vsat is minus of 2.74. I am just trying to substitute what is minus Vsat. Minus Vsat is minus 2.74. Minus of minus 2.74 minus of VTH is 1.8 e power minus alpha A divided by 10k and 0.1 microfarad. So what I'll do now, it's minus 1.5 alpha equals minus 2.74 minus of minus 2.74 minus 1.8 into exponential into minus alpha A divided by 10 exponential 3 into 0.1 exponential minus 6, close, shift cal. Okay, now let me see how much is T off. So T off, I'm getting it like 1.29 millisecond. So this is my on time, this is my off time using the equation. Let me find out how much is my on time, off time. Okay, let us see. Okay, this is my positive width. So let me just compare with my calculated values. Okay, this is 894 microsecond. How much I'm getting here? I'm getting as, okay, this is 908 microsecond. This is 0.908 millisecond is 908 microsecond, which is very close to this. And this is my off time, which is 1.37 millisecond. I'm getting it like 1.29 millisecond. There's no huge difference between the on time and off time. If I can actually find what is the frequency as per this is, so what is frequency is equal to 1 over T, which is nothing but 1 over T on plus T off, which is nothing but 1.29 exponential minus 3 plus of 0.894 exponential minus 3. 1 over that is, it is frequency is 457 hertz. The duty cycle is T on by total T. So 1 over this is this, and it okay, 1 over that into 894. 894 exponential minus 6. So it's actually 40%. So duty cycle is 40% and frequency is 457. So this is the frequency 457, which is there. Where is the, okay, you are almost there. This is 437 kilohertz. So this is very close to this, and duty cycle is 39.70. We are supposed to get 40%. So this way we can able to verify the values. So of course, let me just repeat the way what we have done is we have used this expression for the capacitor voltage, which is a general expression, which is nothing but final voltage. Capacitor voltage at any time is given by final voltage minus initial voltage into e to the power of minus t by rc, where this t is the time of interest, r is the charging resistor, c is the uh, timing capacitor, and vc of t is nothing but voltage of the capacitor at any given time. If you substitute t is equal to t on, then we can substitute what is v final, v initial, and vc at t is equal to t on. So that's what we have written. At t is equal to t on, capacitor voltage is VTH. The final voltage, it will go up to plus Vsat. The initial voltage is this VTL. Then we substitute all this and we are trying to find the unknown value, which is T on here. So that's what I found here. Similarly for T off, I can find what is the expression for T off here. So now in the same expression of the capacitor voltage, we are substituting what is the final voltage. In this case, final voltage is minus Vsat. The initial voltage is VTH. At t is equal to t of, the capacitor voltage is VTL. So that's what is VTL minus Vsat and VTH. So this is your Vc of t, this is your V final, and this is V initial voltage for t is equal to t off. So upon doing this, we got t on as 894 microsecond, t off as 1.29 millisecond. The frequency, duty cycle, everything is as per this calculation. We got the practical values very close to what we calculated. So what you can think of doing is, so you can use these equations of on time and off time. Try to verify the values that you get using simulation. So you can change it to different values of RTCT. Maybe you can just try for different values of RTCT and then match, of course, try to find out how close it is to the expected value. So we are getting very close to the expected value, and similarly while doing the experiment you get the same values. Thank you.